Picture this. You download every movie ever made in under a single second. That is the promise of 6G, the wireless revolution set to redefine human existence by 2030. 6G is the sixth generation of cellular networks, the successor to 5G. But calling it an upgrade is like calling a rocket an upgrade to a bicycle entirely. The numbers are staggering. 6G targets peak data rates of 1 terabit per second. That is 100 times faster than the theoretical maximum of current 5G networks. To put that in perspective, you could stream 8,000 high-definition movies simultaneously. Or transfer the entire English Wikipedia in less than the blink of an eye. Latency drops to microseconds. We are talking 1/10 of a millisecond. Faster than your nervous system can react, faster than the speed of human thought itself. The secret weapon is terahertz. 6G will operate at frequencies between 100 GHz and 3 Terahertz, an electromagnetic frontier never used for consumer wireless before. Why terahertz? Because that is where massive amounts of unused spectrum live. More bandwidth means more data, and 6G needs an ocean of bandwidth to deliver its promises. But terahertz waves are tiny. Their wavelengths measure under a millimeter. They behave less like radio waves and more like beams of light, with all the limitations that brings. The atmosphere itself becomes the enemy. Water vapor, oxygen, even rain absorb terahertz signals aggressively. A heavy downpour can blot out a 6G beam entirely within meters. Solution: brutal cell density. 6G networks need base stations every 50 to 100 meters. Lampposts, traffic signs, building corners, every surface becomes a potential transmitter site. Massive MIMO scales up dramatically. While 5G uses 64 antennas, 6G base stations could pack 10,000 antenna elements into a single panel the size of a tablet. Beamforming becomes laser-like precision. Instead of broadcasting in all directions, 6G focuses energy into pencil-thin beams that track your phone as you walk, drive, or even fly overhead. Artificial intelligence is built into the network's DNA. Every layer, from radio scheduling to traffic routing, will be controlled by machine learning models making decisions in nanoseconds. Network slicing creates virtual networks on demand. A surgeon, a self-driving car, and a child watching cartoons all share the same hardware but get totally different guarantees. Edge computing fuses with the radio. Compute resources sit inches from the antenna. Your phone offloads heavy AI tasks to servers a single hop away with zero perceptible delay. Holographic communication becomes real. Project a life-sized three-dimensional version of yourself into a colleague's office in Tokyo. Indistinguishable from physical presence, transmitted in real time through the air. Brain-computer interfaces gain a wireless backbone. Neural implants stream raw thought data to cloud processors. Researchers believe 6G is the first network fast enough to make this practical. The tactile internet emerges. Touch becomes transmittable. A robotic glove in Berlin moves in perfect sync with a hand in New York, conveying texture, weight, and resistance instantly. But communication is only half the story. 6G networks will also sense the world. Every base station doubles as a radar, mapping movement, breathing, and even gestures invisibly. This is called integrated sensing and communication. Your network can detect a fall in a senior's home, count cars at an intersection, or monitor crops without any cameras present. The challenges are extraordinary. Generating clean terahertz signals requires entirely new semiconductors. Today's silicon transistors simply cannot switch fast enough to drive these ultra-high frequencies efficiently. Power consumption is brutal. Early terahertz prototypes burn watts to deliver milliwatts. Engineers are racing to build amplifiers, modulators, and detectors that work within mobile device energy budgets. New materials are coming online. Gallium nitride, indium phosphide, and graphene-based transistors promise the speeds needed. Photonic integration may even bring lasers directly onto smartphone chips. Antenna design transforms completely. Instead of metal rods, 6G uses metamaterials, surfaces engineered with sub-wavelength patterns that bend electromagnetic waves in ways nature never intended to allow. Reconfigurable intelligent surfaces are walls covered with thousands of programmable tiny reflectors. Software steers the beams around obstacles, turning entire buildings into active components of the network itself. Satellites become full network citizens. Low Earth orbit constellations beam terahertz directly to phones. SpaceX, Amazon Kuiper, and Chinese state operators are building the orbital backbone right now. Non-terrestrial networks integrate seamlessly. Your call hops from rooftop antenna to drone to satellite without dropping a packet. Coverage extends from city centers across oceans and into deep wilderness. High-altitude platforms join the mix. Solar-powered drones cruise the stratosphere for months, providing 6G coverage to disaster zones, war fronts, and remote villages without any ground infrastructure. Even underwater is in scope. Acoustic and optical 6G extensions promise high-speed connectivity to submarines, divers, and autonomous ocean robots, finally cracking the last great connectivity frontier. On the Moon and Mars, 6G principles guide future deployments. NASA already plans cellular networks at lunar bases. The same technology will eventually link astronauts on other worlds. Security demands a quantum revolution. Today's encryption breaks against future quantum computers. 6G integrates post-quantum cryptography from the ground up to protect data for decades to come. Quantum key distribution gets early experiments. Photons carrying entangled keys flow alongside terahertz data, offering theoretically unbreakable security for governments, banks, and critical infrastructure operators worldwide. The network itself becomes a digital twin. Every device, antenna, and packet has a virtual model in the cloud. Operators simulate failures, test upgrades, and predict outages instantly. Smart cities reach maturity. Traffic flows reroute themselves. Garbage trucks optimize routes by the second. Streetlights dim based on actual pedestrian density rather than fixed schedules baked in concrete. Autonomous vehicles finally deliver. With sub-millisecond latency, cars share sensor data instantly. A truck 3 blocks away warns yours of a child running into the street before you see it. Remote surgery moves out of the lab. A specialist in London operates on a patient in rural Kenya through robotic instruments. Tactile feedback flows both ways with zero delay. Industry 4.0 reaches full automation. Factory robots coordinate without wires, swapping tasks dynamically. Predictive maintenance prevents failures before they happen. Supply chains run end-to-end on 6G entirely. Energy efficiency is non-negotiable. 6G targets 100 times better bits per joule than 5G. Otherwise, the carbon footprint of running these dense networks would be catastrophic for the planet. AI optimizes power constantly. Cells sleep when idle, beams steer to active users only, antennas turn off rows of elements. The network breathes with traffic instead of running flat out. Standards bodies are racing. The International Telecommunications Union calls it IMT 2030. The Third Generation Partnership Project, or 3GPP, will release the first 6G specifications by 2028. China leads the patent race aggressively. Huawei, ZTE, and state research institutes file thousands of 6G patents annually, securing a dominant position in the global standards negotiations underway. The United States responds with the Next G Alliance. Industry giants and university labs collaborate to ensure American leadership in the next wireless generation, backed by federal research dollars. South Korea aims to launch first. Samsung and SK Telecom plan commercial pilots by 2028, 2 full years ahead of most international rollout schedules currently announced publicly. Japan, Finland, and the European Union pour billions into research consortiums. HexaX, Beyond 5G Promotion Consortium, and similar programs accelerate fundamental breakthroughs in terahertz materials and AI radio. The roadmap targets 2030 for full commercial 6G. Standardization in 2028, prototype deployments in 2029, mass market handsets and infrastructure shortly thereafter rolling out. But challenges loom large. Spectrum allocation requires global coordination. Hardware costs must drop tenfold. And consumers must believe the leap from 5G is worth the steep upgrade premium. The handoff from 5G is gradual. Early 6G services will overlay existing 5G networks. Phones support both standards. Coverage expands neighborhood by neighborhood as terahertz cells multiply rapidly outward. Privacy debates intensify. A network that senses motion, breath, and gesture is also a surveillance grid. Lawmakers worldwide scramble to write rules before deployment outpaces democratic debate entirely. Skeptics question the hype. Do users actually need a terabit per second? History suggests yes. Every previous generation seemed excessive on launch and quickly became indispensable to modern life. 6G is more than faster wireless. It is the nervous system for a planet of intelligent machines. By 2030, this insane engineering will quietly reshape every corner of life.